right. Hi, everybody. I am Alan C. Smith, Certified LabVIEW Architect and Embedded Developer. I have been building LabVIEW applications for over 30 years at this point, which is a long damn time. I am LabVIEW Champion. I'm a member of the Actor Framework Guild. I have some other guild members here in the front row that have decided to come cheer me on, which I think is fabulous. I'll mention them in turn when I get to the relevant sections. LabVIEW Champion, Actor Framework Guild member. I am JustACS on the forums. I spent the last several years in private practice as a consulting architect. So yes, I am for hire if you need help with your Actor Framework systems. Which is what I'm here to talk about today, is Actor Framework. Now, I talk a lot about the Actor Framework. I see several familiar faces in this audience. Several of you, I'm sure, have seen a number of my presentations. All of them have been about design in Actor Framework, doing cool software type stuff. This presentation is a little different. This is the Actor Framework state of play. It's where we are right now with respect to our tools and processes. This is more tailored for software engineering interests, how we actually get the work done, okay, as opposed to the cool things we do in Actor Framework. Why this talk? Why this shift in, I was supposed to say before we get started, we have microphones floating around. If you want to ask a question, that's great. Go ahead and ask a question. I will pause and wait until you have the mic in your hand so we make sure to pick it up for our recording, and then you can ask your question. So one piece of ground rule housekeeping. Now, back to the presentation. Why this presentation? Why am I here talking about, tools? Well, last year, and it might even have been in this room, but one of these rooms, Norm Kirchner gave a presentation called Design for Debug. And what he was doing was very passionately arguing. Those of you who know Norm Kirchner knows he argues passionately about everything that he cares about. But he was arguing for proactively augmenting our designs with a mindful compassion toward the person who needs to debug your code. It's a reminder that this making software is a creative human process with real human beings who have families and lives and hopefully things they care about other than just their code. And he was explicitly asking us to make explicit design choices which intentionally enable or accelerate the inevitable process of debugging. That's what he was worried about. The whole point of what he was talking about was he's like, look, you write code, you write some technical debt, right? That's the work you're going to do because you did some work as a direct result of the work that you've done. That's inevitable. It's going to happen. He likened the process of debugging as interest payments on your technical debt. If it's harder to debug, your interest rate is higher, was the analogy that he was making. And I think it's a really good one. So his argument was, what can we do to lower that interest rate so that the extra work that we have to do because we've done work is easier, takes up less of our time. And he was demanding that we build tools, techniques, and processes that give us insight into the code that we write. And insight is a tool that gives us information that leads to identification. So things like execution highlighting will give us information about where a bug might be. Okay, and then accelerators. An accelerator is a tool that helps you drill down through all the layers of your code to the bit of your code that is at issue. And he gave this presentation, and in the course, he had a range of developers that he was talking about, from our test engineer who doesn't really do software development, but he's just working on his benchtop, trying to solve an immediate problem, all the way through a couple of grades, all the way up to senior architects who are building frameworks for other people to use. And of course, in doing so, he talked about our two most common and popular frameworks, DQMH and Actor Framework, and he talked about some of the tools that are available for those two frameworks. I'm sure most of you have heard about one or the other of those. Well, you're here, so you've heard of Actor Framework at least. And as I'm watching this presentation, I'm like, oh, okay, that's great. Norm has done a really good job of that presentation. He's brought a few things to light, and I thought, we should probably have a presentation that brings all of that together specifically for Actor Framework. He missed a couple of things that I would have included. He only had an hour. And there were some things I thought, we'll expand a little bit past Norm's initial mandate and take into account sort of the entire picture of producing code in Actor Framework, what that might look like. So that's why I'm here today. And I thought NIConnect would be a good venue for this. So what does Actor Framework offer us from a software engineering perspective? I think it's great and beautiful from a design perspective. I can do really cool stuff. But I've also found that on the engineering side, it has a lot to offer as well. First and the most obvious, and this is true for any good framework, is that a framework takes choices away from us. There are several ways to solve a problem in software. Any given task that we need to do, there's several ways to do it. And a framework says, you're going to do, for where we're using this framework, you're going to solve this problem in this way every single time. That's its job. And it makes our lives easier because we can just go and do the thing that we know is going to work here. So in Actor Framework, we get a structured and organized approach to software development. Okay, I'll talk about that. It also was always envisioned that it would be make it easy to build reuse libraries. All actors are actors. They all, in theory, can talk to each other. So in theory, we can make a pool of tested, reliable code modules, that holy grail that we always talk about, that we know we can pull on that are already tested. One way to reduce technical debt is to not take the loan out in the first place, right? So if I can use something really awesome that Casey wrote that I know he's used in a lot of places, then great, that takes a load off of me, and that's a bit of the code I don't have to worry about. There are workflows in Actor Framework that if you are coding to the way the framework is designed, will tend to improve your initial code quality and will accelerate your ability to find and correct bugs. Sometimes we know the bug is not here, which is again, a useful insight. I know that this part works. I'll talk about that. And then I'll wrap up with talking about our transparency tools that we have that give us that insight and rapid access into the code base. Quick show of hands in the room. How many of you consider yourselves proficient in Actor Framework? Okay, a fair number of you. How many of you, you've seen Actor Framework, you've tried it a little bit, you've maybe done a little bit of coding, maybe one project, you've tried a little, you're not comfortable with it yet, but you have a sense of what's going on there. And how many of you, okay, a fair number of hands, good. And how many of you are like, I've heard of Actor Framework, I know very little about it, and I think I'm gonna come check out a presentation. And a fair number of hands, okay, cool. So about half of you are my target audience for this presentation. That's my last two groups that I asked about. Okay, my proficient guys, and I'm looking at you three in the front, are probably already know everything that I'm going to talk about. Now, maybe for you guys, it'll be handy to see this in one place because you can take this presentation, it's recording, and you can go to your newly onboarded engineer and say, hey, we do Actor Framework in this shop, watch this video. Maybe it'll be helpful to you in that regard. But I just want to set expectations for the folks in the room. That's kind of where we are and who my target is today. All right, so a brief overview of Actor Framework. I tried to come up with a useful elevator speech that doesn't dive too much into the detail of how it works, but just gives you a sense of the problem we're trying to solve. Here's a fun fact about LabVIEW applications. 90% of them, my sources tell me, use some sort of parallel processing, multiple while loops that talk to each other. It's either producer consumer at a very basic level, or you get past that and you very rapidly wind up here with a message handler. Okay, does that look familiar to everybody in the room? This happens to be my template from years ago. Everybody's got their own, which was part of the problem, right? Everybody had their own way of doing this, little tiny variations of the same thing, and they wouldn't all talk to each other. But our applications were all built on this. And if you remember back to when the certified LabVIEW developer exam first came out, before there was any other exams for LabVIEW, you solved it with this. Because so many of our applications, this was the one thing that you had to have. And then of course we learned that it's message handlers all the way down. I can have more than one. I can have them talk to each other, right? And we've been doing this for 25 years. And I mean, I still come across systems like this. It's still, that project template still ships with LabVIEW. And it's a great tool. I've done a lot of good work with this. I know a lot of people have. You have multiple parallel processes. They talk to each other. Every module has some responsibility, and you solve a problem by having them talk to each other. Our modern frameworks, the ones with which I am familiar, I know a couple of them pretty well, and I have a passing acquaintance with a number of others. All they are at their core is we're going to take that concept and we're going to wrap it up, give you a standard way of producing them, and then we're going to give you tools to make that easier, right? DQMH, Active Framework, the two biggest ones in the field that people are familiar with. There are others, but the big differentiators between these, and if you ask the DQMH folks, they'll tell you that's the biggest thing that DQMH does for you is give you tools to make this easy. Active Framework is the same thing. We solve the problem a little bit differently. Active Framework is object-oriented, class-based, and that gets a lot of benefits. I, of course, am talking about that one today. There are other presentations. Actually, the DQMH one is going on right now. But you can find out about DQMH in a whole raft of other venues. We're going to talk about Active Framework today. So what is an Active Framework? You get a standard template for actors. An actor is a class. It's a class that wraps up a queued message handler. It's a standard template, and all actors in an Active Framework system are based on it. You get a standard methodology for exchanging data between those actors. They all do the same thing. They all interact in the same way. You get dynamic launching, which lets you do really cool things like have an actor that comes and goes in your system. Imagine a user interface panel that is only present for a short period of time, or a network connection. If you're not connected, the actor is not running. It's not even present in your system, but as soon as you connect, it's there. You can have multiple instances of the same actor in a system. If I have, 3 little Visa devices that I need to talk to at the same time, I can have 3 of the same actor doing it. Code supports that naturally, natively. And then, of course, as with all frameworks, you have a set of tools for rapidly building all of this. That's what comes shipped with LabVIEW. And if you're trying to convince people to use Active Framework, hopefully you now have an elevator speech for it. As I said, kind of moving on to what it offers us and how we work with it. As I said, the job of a framework is to take choices away from you, to give you a standard set of choices for solving whatever issues that framework is intended to address. Active Framework is about parallel processes talking to each other. You have a standard code organization. Actors have a life cycle. They are launched, they run, they are disposed of. And then there are hooks inside of the actor. There are places where things happen. So there's a pre-launch init step that happens when you launch the actor, and that's where you do all your instrument setup. Then you go into steady state where you're handling messages, and when you're done, there's a place where you shut everything down, and we actually notify the caller of, hey, I have stopped, and there's useful information that is returned with that message. Key takeaway here, the actors have a life cycle and specific spots where specific things happen. So if you know you have a particular type of problem, the actor's failing to launch, well, there's probably something in pre-launch init that isn't right, and that's the place to go look. Okay, we've organized the code here. And then you add, of course, your own methods on top of that for the specific things that you want to do. Actors inherit complex behavior from other actors. So, if I have a complex actor, this is an example from the Active Framework course. It's a cooling system, a residential cooling system, as the example. And at its core, it's an actor class. Yeah, okay. Do we do message handling? Well, maybe you have to pull a serial device. You can't wait for it to send you announcements. You have to be constantly asking it for its data. So maybe you build in an inheritance layer that gives you a message pump that just does that update every 10 seconds or whatever. And then maybe you need another layer that's logic, what you're doing with that information. And then finally, there's maybe a layer where you're managing the life cycle of other actors in your system. My point is that every layer has a function and a purpose and functionality that it provides. And if I have a problem, with how often my updates are occurring, I know where to go look. I look at that layer. It's not going to be down here. Well, next slide. It's not going to be here, right? It's going to be there. So again, because of the way actor framework systems are laid out, there is information about where to expect to find your problems when they arise. And of course, we build complex systems out of our complex actors, right? And so, each of these actors has a specific task that it does, that may be a complex task involving multiple types of operations, but then we combine them together to form a complex system that solves a larger problem. And then, of course, our features, at the highest level to look at, a feature is essentially a single line of messages moving through this system, or maybe a couple of branches of messages. Okay, so if I know I have a problem with a feature, I can go in the other direction. This feature has a problem. Okay, I think it happens to be in how the cooler is responding to a piece of data. So I drill down and look at the cooler. And then maybe it's a layer in the cooler. It's how I'm updating, right? And so if I'm following the way the framework is intended and laid out, and I've taken care to adhere to that sort of philosophy, I already have a general idea of where it's supposed to be, okay? Know your framework, know how it works. By the way, I will say that this inheritance versus composition, right? I can make a complex actor out of several layers of inheritance. I can make a complex system out of several actors working together. It gives me a lot of granularity with where I can put my whatever bit of complexity, whatever bit of code that I need. Because if you think about it, right, all of our coding tasks, the coding tasks are just the tasks, and there's got to make a DAC call, or I've got to access a file, or what have you, but we've got to put them somewhere. And we have a lot of choices, and if we're intelligent about how we do that, it makes it easier to maintain the system going forward. All right, so we have a sense of how we want to lay our code out, and we've mapped it to how Actor Framework works. So hopefully we've got a good starting point. We have another good starting point, and this goes to maybe taking out less technical debt to begin with, and that is development libraries. And we do have a number of them available to you, some for free, some not. Here's the free ones. If you go to VI, everybody's familiar with VI Package Manager? Okay, if you go to VI Package Manager and you search for Actor, this is the list of available packages, available free download packages for Actor Framework, things that are available to you. A lot of the tools that I'm going to talk about today are available here. Other entities have built their own reuse libraries that are perhaps, you have to pay for. One example is TesterACT's HAL system is actually entirely Actor Framework based. That's another framework built on top of the Actor Framework. So that's another option as a place to start. I need to build a test system, and I can start with this Actor, with this base. This is not everything available on vipm.io. You actually should go to the website where there is a curated list of Actor Framework packages. Not all of them have Actor in the name, but that's where you would go find this stuff. Now, what are you going to find if you go looking? You'll find some tools, and I will talk about those. But in terms of reuse libraries, you're going to find two types. You're going to find plug-and-play actors. These are actors that you take the actor and you drop it in your system somewhere, and you have it messaged to other entities, and you're good to go. You don't have any other work to do. Somebody else has solved the problem in the system for you. The other type of reuse actor you will find is an inheritable actor. This is intended to be one of those inheritance layers in the building of a complex actor, and it solves whatever that layer of complexity is for you. I'm going to start by looking at a plug and play example, and that is my very own network endpoint actors. This solves the problem of, so Actor Framework happens to be, because of the nature of multiple parallel processes, multiple actors talking to each other, that maps really well to a distributed system. Because if you think about it, your desktop computer and your CRIO are really kind of two actors that are running in parallel and have to talk to each other. If you're building up that hierarchy of AF code, so you've got something running here, you've got something running on the RIO, they have to talk to each other. You're sending something across a network boundary. Network endpoint actors are here to solve that problem for you. The idea is that you have each of your two distributed applications has a network endpoint. They find each other when your local code needs to send a message to the remote. It sends it to the nested endpoint. The nested endpoint, network endpoint, sends it to its remote counterpart. The remote counterpart forwards it to the rest of the system, okay? It supports TCP/IP and network streams, and it is user extensible in a number of interesting ways. You might track down my serializable messages presentation from the 2021 GLA Summit for an example of what you can do with this as a starting point. But this solves a problem for you. Lots of people have used it. This is tested code. You can even go get the unit tests and prove it yourself. And so that problem is solved. If you have to do this, check this out first, see if it'll work for you, save yourself some time. On the inheritable side, I have two examples. The first is state pattern actors. This solves the challenge of I want an actor that has behavioral state. Behavioral state is this idea that, and the example that I'm showing here is a numeric keypad like on your computer, right? Got this keypad off to the side. If it's in one mode and you start typing, you're gonna move your cursor around on your screen. If you push the numlock button and you start typing, you're gonna be entering numbers, okay? That is one object, one actor, if you will, that responds to the same message in a different way depending on the mode that it's in, okay? It's a very common design pattern for class-based systems. Its implementation, and it has an implementation in Actor Framework. This is the numeric keypad example. We actually cover this one in the Actor Framework course, Actor-Oriented Design in LabVIEW. And you can see on the left over there is a state diagram. You see the two states, a cursor or a numeric keypad mode. And you can see the key pressed method shared by both of them with completely different results depending on the mode that you're in. So if you need this functionality, as an example of what I'm talking about, if you need an actor that can do this, you can go to vipm.io, download state pattern actors, have your actor inherit from it, and it gives you a standard mechanism for managing state transitions, and then you build your actors on top of that, okay? That's one example. I have another one. This one is awesome. And I've known about it for years. I'm finally doing some complex UI work. And so I've started to use this, and it's a truly awesome bit of kit. This is the panel manager from More Good Ideas. This Derek Trepanier did this when he was there. And what it does is it lets you effectively and easily build complex. We see customers want these big user interfaces with lots of stuff going on them, right? And that one monolithic user interface can be really hard to work with, really hard to build, really hard to maintain. And so what you do with Panel Manager is you actually make your UI out of several actors using subpanels. Each a little, I saw the light bulb go on right there. It's a fabulous idea, right? And so, you have a main panel with subpanels in it. Each subpanel shows off an actor. That actor can be a small portion of your UI that you can pop out and test. You got a big grin on your face too, because you're using it, I'll bet. It's a great piece of kit, and I have a little demo, actually. Let me go ahead and call it up for you. By the way, don't ever write, if you're doing Actor Framework, don't ever write an X control. How many of you know what an X control is? I've written them, and in LabVIEW code, yeah, sure, great. Regular LabVIEW, I'll write an X control. If you're in Actor Framework, do this instead. Or Q would like you to use as Q controls. But you can do this. You can do these complex things. This was actually my first exposure was we were doing, customer application was going to be in a clean room. They had a 600 by 800 monitor, and they were double gloved and the touchscreen, and the regular LabVIEW controls were all too small. So we had to go back and redo a bunch of LabVIEW controls. They're big, fat things that you could fat finger whatever you had to do. And so we were recreating these controls as actors. It's really awesome. So this is a project of projects. I'll talk about what you can do with that in just a minute. Let me go, where's that guy? Come on, there we go, cool. Here is his composite user interface. This is an example that ships with the package. I'm just gonna run it first. And it's gonna show up over here. Right, so here's a complex UI, and I've got a part where I can go make up some data sets. I can grab a data set and I can drag it into this graph. 2 instances of the same graph. I get 2 different data sets. I've got some text information over here about what the example is supposed to be doing. I can pop out a window. It's the same kind of window, but now this is a dialog box, right? Or a floating panel, rather. Okay. Now, if I go, this would be a lot of work to do and a lot of repetitive work to do on a regular LabVIEW front panel. But if I go into here, let's just show this off, right? Here is the Actor Core for composite user interface. If you don't know, all UIs in Actor are the Actor Core method, just showing the front panel. There's the 4 subpanels. That's all this does, is manage the launching of some subpanels and maybe the messaging between them. Under support, here is the tool that generates data sets. Right? So that's the actor that just generates data sets for you. That's all this guy does. So it's really easy to test, right? Data viewer. Here's this basic data viewer. This can show up as a subpanel or as its own window. Okay. And of course it resizes as it needs to resize when it gets dropped down in the subpanel. And yeah, that's all I'm going to say about that. But honestly, go download it and check it out. It is, as I said, a fabulous piece of kit for making all of that so very much easier. And these are the kinds of things that you can do with Actor Framework, make these reusable components. And you can go all the way up again to, as I mentioned, TestDirect has an entire test suite that is the foundation for your test application that is built on Actor Framework, which is the same concept, sort of writ large. There, see, it was worth you showing up. All right, that was my demo. Here's an example from my own work. I have a customer who really likes him some big panels for configuring his devices, and that's everything I do for him is we're managing a whole family of devices, mix and match to do his tests, right? And he loves him some complex panels. And some of those pieces are common to all of his instruments. Some of those pieces may be common to certain types of instruments, and some of them are going to be specific to that model from that manufacturer. Okay, and so we are in the process of, and I set up a framework for him, and then he's had his own people go make a ton of these. And we've realized that we have all these common components. And so we're in the process of going back through, reworking these panels with these subpanels. Each one of these, by the way, contains a kernel, a bit of the configuration. And so when we're done, we roll all those pieces up into one big config token and save it to disk, right? Usual housekeeping stuff, we've all done this 1,000 times. But with these subpanels, it becomes a lot easier. This whole thing is a subpanel that drops into a big instrument configuration tool that he can look at all of his instruments in one place. And we're starting to add in access to soft front panels from here and so on and so forth. So that's what one looks like in the wild. Not the prettiest front panel in the world, but there's a lot going on, and we're making it simpler with reused components because we found we were doing the same things over and over again. I'm going to wrap up this section with a call to action to all of my proficient developers. Look at you guys in the front who've already delivered some things I want to talk about. And those of you who wish to be proficient. Do this! This list is too short. We need more stuff. Right? Our state of play is that we need more stuff here. You're all doing fabulous work. You're all doing things that are of interest that you never want to write again. And if you never want to write it again, I sure don't. Okay? You know, Casey sure doesn't. Let's not do that. Let's stop doing that. If you have a cool, even if it's just in your own organization, because I know some of you a lot of you work for organizations that just hold on to anything you produce just in a tight fist, right? Even if it's just in your own organization, start doing this. You can have your own repos. You can just put stuff in source code control and say, go get the latest package from here to solve this problem. Do this. If you can, wherever you can, package it up and share it. Jim Crane at JKI and his people have made it very easy. Actors package up beautifully into VI packages. And Jim Crane and his people have made it really easy to make the stuff available to the community. Right? It's a fabulous way to advertise how cool you are, honestly. So if you're a consultant in the room, put some stuff up here. So that's a call to action to you guys. Okay, so that's what we have to get started with. Probably ought to start to loop back more toward what Norm was talking about in terms of enablement tools. And that's what we're going to do next. We're going to talk about support for our workflows. One thing that DQMH does that everybody seems to really like about DQMH, if you ask them, it's probably in the top 5 things that people like. When you make a DQMH module, one of their actors, you get a hand tester. This is a little test harness. It's just a VI that will launch your DQMH module for you and let you poke messages into it, see the messages come out, and log the results. Not many people. How many people knew that a tool like this exists for Actor Framework? Those of you who know Actor Framework. 3 people know. 2 of them, and all 3 of them I know personally. I'll get there are issues with this tool. I will get into it in just a minute, but it has existed since 2017 or 2018, I think, actually. I think it was written in 2018, LabVIEW 2018. I'm gonna go pull this up, and you'll notice I'm picking pre-interface version of my code. And I have a reason for doing that I'll just talk about in a sec once I can get that. There it is. I really need a monitor right here that is an echo of this. All right, so here we go. So here I have a project. I happen to have this cooler that I've been talking about is sitting right here. I have a hand tester for it. If you were to make one of these from scratch, you would find down, Sam Taggart at SAS Workshops did this tool. So that's why his icon's down in the corner. I gotta give him full credit. If I went here, I would be able to make a new actor tester or rescript it. Takes a few minutes, well, not a few minutes, but it takes a little more time than I wanna take in a live demo. So I'm not gonna do that, but you can go do that with your own stuff. But if I launch this tester, and I get this guy for my cooler. And I can change my set. I can launch a cooler. I can send a message to that cooler or any instance of it. I can set a value here. I can send it. I can send a launch panel message, right? Don't have enough screen real estate. Oh, yes, I do. I can. Come now. It'll stop the actor. I can't quite see the button, but I can shut everything down and it'll shut my actor down for me. That's cool. That's really handy. Especially if you're doing user interfaces, which are hard to unit test, right? It's nice to have the flip side panel. This is the state of play, so I'm here to be honest with you guys. And that honesty includes my telling you that this tool has some real problems that it would be lovely if a community member would address. So, who here remembers abstract messages? Who here would like to forget abstract messages? Okay, this tool doesn't support abstract messages. If the actor in question receives an abstract message, the tool does not know how to build one of those. Abstract messages are deprecated as of LabVIEW 2020 SP1, so I'm not worried about that. You can't write one of these against an actor in a PPL. Again, this would be a development tool. I'm not worried about that. The bad news, the thing that's really the deal breaker right now, is that this doesn't reflect any of your inherited messages. So if, remember I talked about that complex layer of inheritance, every one of those layers can conceivably contribute a message to what the final actor can do. It would be really lovely if this tool rolled all these up and gave you the full suite of messages the actor can receive. It doesn't do that, it just does the current inheritance layer. That also lets out your interfaces to your actors. I strongly believe interfaces early. Often it's rare that I have an actor that has its own message anymore. They all come from interfaces. That makes this tool a deal breaker in that environment. Now, I don't think it would be hard to fix. I think it would be a simple matter of this actor, what does it inherit from? What messages does it have? And just iterate on that until you have the full message list. Should be easy to fix. Haven't gotten to it. If somebody in this audience, maybe I'll get to it, maybe I'll get inspired, but if I don't get to it, maybe one of you fine folks would be like, that's really useful. I want to go solve that problem. Get in touch with me or Sam Taggart if you know him, and we'll get you rolling on what you can do to make that better. Now, why? I'm a big actor framework guy. Most of my work is in actor framework. Why haven't I gotten around to fixing this? Any guesses? It's actually because I do this instead. My workflow for actors involves a lot of automated unit testing to the point where I already know what the actor's gonna do if I send it a message, which I would love to have the hand tester for my UIs, but for most of my work, it hasn't been that critical. I have used VI Tester, I have used Karaya, I've switched over to Karaya more recently. The other test platforms should work equally well. Unit test frameworks doesn't really have classes in mind, but if it's got classes in mind, it'll support actor framework well. So I give Karaya the nod. VI Tester is in maintenance, still a fabulous product, but in maintenance because Karaya in a lot of ways is better. So how do you unit test an actor? How do I do that? Well, I write my actors, and this is actually going back to Norm's be mindful of how you write your code to make things easier for the people that follow you. I write my actors so that I can isolate them. I can have the actor by itself, without its caller, without any of its nesteds, in its own little project. And then once I have that, there are some really simple tricks for building a test harness around it, where what I can do is I can send the actor the message, and it's only going to do a couple things. It's going to change its internal state, or it's going to send a message, right? That's all actors do. So I can intercept the message back to the caller or down to one of its nesteds. I inspect the message for its data. If I get the right message with the right data, that test passes. Maybe the actor itself has changed internally. So maybe I stop the actor and I look at its internal state, because you can do that. Okay, that's what I do. That is core to my workflow, and we've actually recommended from the beginning that you always test your actors in isolation. That has never changed in the entire history of Actor Framework, and really automated unit testing is the way to go. Needless to say, interfaces are your friend. We have a question from this gentleman right in the front. Where is his mic?
When you test your actors, you actually run the actor itself, or do you just call the methods?
Yes.
Okay.
You can do both. Without going, I don't have time to get deep into it, but you can actually do both with the actor. If what you're doing is testing things like internal state, and you're not sending messages somewhere else, then you don't need actor core for some reason. There isn't some process in actor core that you care about. You can test it like any other class, right? As I think you already know, based on your question. But usually, actors do three things. They send messages, they launch other actors, or they change their internal state. So you can test change internal state statically if you wish. But if you want to check messages getting sent, it often requires, just because of setting the queues up and stuff, it often requires that the actor be running. And then if anything in actor core is going on that's interesting, then it has to be running for that as well. There are techniques for both. Let me show you real quick. This is what it looks like to test it where the actor is running. The setup is, I didn't show you, there's a lot going on in that VI, doing some queue setups and things like that, but that's where I get the actor set up and running. Once it's running, I send a message, wait for the response, and then I check, I inspect the message that comes out the other side. If I don't get a message, or the data in the message is wrong, my test fails. Right, I still have more work to do on that part of the feature. But if those things are all correct, then my test passes. And now I have useful insight into my actor in a sense that I know that this thing works. So if I have a bug, it's not in this behavior. Okay, I know I don't have to look here. Eli's got a question. By the way, while he's getting the mic, I'm not going to say too much more about the techniques here, but I will refer everyone to. I gave the first presentation on this in 2019. This video is available from America's CLA Summit 2019. It is test-driven development with Actor Framework. That whole workflow is laid out for you there. Takes about 45 minutes. This got turned into lesson 13 in the Actor Framework course, so we teach this as the way to work with actors. Now that Eli has the mic, go ahead.
I mean, first off, super cool. I'm learning so much. I'm a big Actor Framework fan, and I'm years behind in my knowledge. But
I live here at Eli. Call me. We'll have lunch.
Yeah, I got to learn this whole interfaces thing. But when you do your unit testing, do you typically integrate those into the same project that you're writing the code in, or do you have a separate project where you keep all your CRI tests?
Fabulous question, Eli. Thank you for asking it, because he's no, he's not a plant. That was a great question, and you went right where I want to go. And this again goes back to insights and accelerators. I have typically a project for every actor that I write in a system that I am building. The actor itself, and the interfaces that it has, any classes or other VIs that it needs to do its job, and all of its unit tests. And that winds up taking usually about a screen's worth in a project, which is about all I can look at anyway. Okay? And it means that I'm isolated. I don't have anything else. I don't have anything else that might cause a conflict. I don't have an extra copy. I don't have a child of a class loaded that might confuse things, right? I just have that one actor to work with. Now, that means if I have 47 actors in my system, I have 48 projects, because you're gonna have the master And it might be 50 or 52 because I might have a few intermediate stages that I'm working with. So that's where that project to project comes in. And this actually, while I was thinking about this presentation and thinking about some of Norm's suggestions, I asked myself why I haven't been doing this, but I've started doing it now. I'm now taking all of those individual single actor projects and I'm starting to put them into a master project file, because you can do that. Your project can have projects in it. They don't do anything, it's just a reference link. And you'll notice it has no dependencies, which is great, because if you've ever loaded a big class-based system, it can take a little while. Even if you do your job and partition things correctly, take a little bit. This loads real fast, has no dependencies, pointers to every project in my system. So if I know a certain actor is malfunctioning, I'm gonna double click and go right to that project, and I can run the unit tests, and the unit tests are gonna tell me where I don't have to look, right? And I can start drilling down that way. Now, when you've done this, if you're doing this, you're plugged in, you're set up naturally to go to unit test, to go to CI/CD, continuous integration, continuous development. The testing frameworks, to a varying degree, depending on how current they are, have support for plugging into your CI systems. So you can totally automate this, make a change, check it in, walk away, find out if my test passed, right? And so that's unit testing. That's the core of my workflow. And I strongly encourage you all to look at it, because it makes your development so much simpler. It makes going back to the project to figure out what happened so much simpler. And it just, this is, if you don't do anything else I talk about, do this. Okay. I will mention one more development accelerator. This is another tool that is available, not really something that gets into the debugging aspect of things, but I'm finding it's an important tool. Events for UI actor indicators. Who's heard of it? Okay, again, it tends to, fewer people than I thought. So let me tell you about this tool. This is awesome. You actually kind of get two tools in one when you download this. The first one gives you an ability to create an actor from a template that you specify. And you get one template, and that template is a UI template. When you create a UI actor from this UI template, if you put an indicator on its actor core front panel, you can right-click on that indicator and add event support. And it will go through and it will add in pre-launch init, it will add in stop core, it will add on actor core's block diagram, all of the user event structures you need to go from any given method of yours in your actor and push data out to the front panel. Okay, this saves you a tremendous amount of time and tedium. It does indirectly link back into our issue of technical debt, because if you're doing the same thing the same way every time with a tool, your odds of creating a bug in that tool go way down. Okay, and again, I'm doing a lot of UI work, and so again, Sam Taggart and I wrote this tool together, and I'm reminded of how incredibly useful it is to have that automated for you, that very tedious task automated for you. Has a few issues, being honest. It does, and these are things that I'm looking at and I need to change that. And because these are like pain points for me today, the odds of my fixing them go way up. We tend to fix the things that cause us pain. It saves that new UI actor to a fixed location, which it may not be the one you want. And it puts an undesirable folder structure around the actor, which is that the library and the actor and all of its methods wind up in the same folder. So I'm finding that when I go make one of these, the very first thing I have to go is go move it on disk. That takes me, probably less than a minute, but that's a minute I could be doing something more useful. So that needs to get cleaned up. Diagram cleanup is non-existent, so I have to go to those panels and click the broom button a lot. That's something that we could automate. And it would be handy if it gave me a VI that did the actual event generation for me, not just create the structure, but at this point, drop this VI, wire the data in, the event gets made. That would save, again, several mouse clicks. These are all pretty minor. This is a very useful tool. But again, probably should get cleaned up they will get cleaned up when I don't know. And if somebody wants to help with that, again, please feel free to reach out, because the Actor Framework is a community project. Those are your workflow accelerations that I would recommend that you look at. There may be others of which I'm unaware, but those are the ones I'm aware of. Now, your system's built, or portions of it are built, portions of it are deployed, they're running. The inevitable bug reports are coming in. How do you know you're going to get bug reports? Your customers are using your code. Okay, it's a good thing. Getting this feedback is good, right? It means they're using your stuff and they're finding the places that need to be addressed. So we're going to need ourselves some insights and accelerators. Going back to Norm's initial thesis, right? What do we have in Actor Framework? And it turns out we have not as much as we might like to have, but we have a pretty good set available to us right now. I'm going to talk about a couple of insights first. The first one, and this one ships with the framework. Desktop Execution Trace Toolkit. Who's used it in some capacity? A fair number of hands. Well, if you go add that conditional disable flag to your Actor Framework project, and then bring up DETT and look at your user-defined event traces, when you start your Actor project, you will get trace events for all of these instances. When an actor is launched, when it stops, when an entity sends a message to an actor. Doesn't have to be an actor sending the message, could be something else. When an actor receives a message, when the time delay message does various things, you get this trace. An enterprising individual could take this information, save it to disk, and write a tool that would turn that into a plant UML sequence diagram, which would be another really nice piece of kit that somebody could do for us. And maybe I'll have my intern do it this summer, right? I have an intern, it's my daughter, she's awesome. She did a tool for us, she helped me with a tool, which I'll talk about in just a minute here. But yeah, so that's there and available to you right now out of the box. Don't have to download a thing. Now, at this stage, I have to mention what is actually the most successful Actor Framework related download in the history of Actor Framework, and that is Monitored Actor, which again, Derek Trepanier, more good ideas, gave us this fine tool that a lot of people like. A lot of people really like it. What does it do? If you're set up properly, and I'll talk about that in a second, when you run your Actor system, and this is great if it's an Actor system you're not familiar with. So that's really where this shines. But if you run that system, you'll get this dialog, which will show you the entire actor hierarchy tree, every actor that's up and running. And it constantly updates real time. And then if one of those actors is behaving oddly, you can accelerate and go to its actor core. You can ping it to see if it becomes unresponsive, you can ping it to see if that actor is unresponsive or if something else is hogging the system up. And if you have to stop an actor because it got orphaned, that's easy to do as well. This is a tremendous help to a lot of people, 14,849 of them as of last Friday. And I have to say, I have to qualify it because as I was writing this presentation, I put that down and I kept going back and checking and it kept going up, 50 or 100 a day. Really insanely popular tool. Derek did a fabulous job of identifying and meeting a need, and I hate it. I don't. Again, Derek did a fabulous job and he worked with the tools that he had. But why do I hate this tool? I hate this tool because in order for it to work, every actor in your system has to inherit from monitored actor. Drives me crazy, okay? If you don't want that, if you've done that is debug code. The ifdebug trace, that's all hidden behind the conditional debug symbol. You turn the symbol off, it's compiled out of your code. This is stuck there. And if you take it out, you've changed your code. You've changed everything under it. Revalidate everything. That's just awful. But that, so that's one problem. And then of course the other one is, if you want to use some reuse code that does not inherit from monitored actor, it will not be monitored in your system. So if you're doing what I just asked you to do, which is to go leverage other people's code, and they're not using monitored actor because they don't like that, half your system is not going to be monitored. So you're really kind of limited. Derek did a fabulous job with the tools that were available to him. Okay, don't want to say any bad thing about more good ideas than their people, because they did a fabulous job. And there are hooks in Actor Framework, in AFDebug trace, that let us do the exact same thing without having to have monitored actor in the equation. And it took a little while, but last summer, my intern and I finally got a user tool into the user's hands that does exactly the same thing. It's called the Actor Hierarchy Inspector. Uses the AFDebug trace functionality, gives you the same thing. Go download that instead and use that, is my recommendation. Let me demo those.
So, I have a question for you.
Give that man a mic while I'm bringing my demo up.
So panel manager right now is inheriting from monitored actor.
What a fabulous question that I will answer in just a second.
Did you make a new version of panel actor?
I did. All right, fine. We'll do that and then we'll do the demo because Q is going to cause me problems if I don't. Sorry. Yes. I did mention, because Q's paying attention, that panel manager, because Derek wrote it, they wrote monitored actor, panel manager requires that because Derek saw, yes, if we're going to do panel actors, I want them to be monitored. So he did that. That dependency is there. And so if you want to use panel manager, you have to download that and monitored actor. Now you don't have to use monitored actor. You can go to panel actor and change its inheritance and take out that link to monitored actor, and it'll work just fine. But you still have downloaded this extra package that you don't need, and I hate that too. So with MGI's blessing, not their endorsement, right? Just their blessing. I talked to them and they said they're comfortable with me doing this. I am currently using a version of the MGI panel manager that is unmonitored, that already does that work. And then I also forked the examples for my customers, because remember, one of my customers does a lot of his own work. He needs to have the examples. I took out the dependencies in the examples on monitored actor as well. And I have included a first version of a template for use of events with UI indicators. Right? So if you go use that template, you'll have panel actor and you'll have event support. Not quite ready to publish. I did make the repository publicly available. So you can pull it down, take a look at it, start to use it, send me feedback within the next few months, because I need to put this in my customers' hands. I will be posting this package to vipm.io. And if you need it in the meantime, find it on the repo. If you have any problems, reach out to me. Now I'll do my demo, Q.
Sorry.
No, you asked. The questions I'm getting are going right to slides. It means I've done my job well. Okay, let me pull up real quick. I want to show this, and I got to be real quick on this because I'm starting to run out of time. This is the cooler project from the class. Let me pull up execution trace. I should have had this up already. My apologies. Hello, where'd it go? There it is. There it is. Okay, cool. So here is the ETT. I have just use define traits turned on. Let me turn that on. Let me bring up under AF tools, and I'm gonna make a pitch, Casey, for going forward that we start putting all of our tools in a common location. We should all have our names on our tools, right? Don't get me wrong, but let's make it easier on people to find them instead of having to hunt down tools in 47 places, right? So here's the actor hierarchy inspector, and boom, let me launch the cooler. It's up and running. There's its front panel. There's my guys. Here's another panel that's running. Here's the traces going on. This is a polling application, so you're seeing the polling messages go out. If I want to look at, say, the cooler's block diagram, there it is, right? I can stop a single actor. It'll drop out of the system, and I'll stop getting water level updates. Eventually, it'll stop. There we go. If I stop everybody, that's an e-stop, so it throws an error message back to you, but that's all correct and appropriate behavior. So those make it easy, especially if you're looking at an unfamiliar system, to get to what your structure is. So now you'll know the structure. Knowing the structure, go back to what I said at the beginning, now you know where to start looking. I will mention 2 accelerators, and I'm so glad the JustACS Solutions guys are here, because those are the 2 accelerators I'm going to mention. The OpenAF payload method utility, you're on a block diagram in an actor, and you see a place where you're sending a message somewhere else, and you really want to know the block diagram that's invoked by the message you just sent. This will take you right to it. That leads into Browse the Browser, which is one of the most awesome things to come along for Actor Framework developers in quite some time. I'm going to demo that tool very, very briefly because I'm almost out of time. But again, I don't remember which GDevCon it was, but it was a recent one, last couple of years. Casey got up and demoed this whole tool in a video. Go watch that video, or just ask the man right there. Raise your hand, Casey.
The video is not that good. I've realize there were problems, technical issues with that. So, but you can ask me about
Yeah, start with the video, talk to Casey, he's very approachable. The tool is actually really, let me double it. The tool is actually really intuitive. Boom, okay. Going back to my, where's my mouse? There it is. Going back to my guy right here, I'm gonna start with, so I gotta scroll down to Zaya, browse the browser. Browse the browser comes up, there he is. Yay, he's awesome. And there was something very specific about Bowser being spelled with a Z, having to do with copyright that Casey can tell you about. Here I have every single one of my actors listed. And you can see down here, here are the available messages for those actors. And yes, it does include messages it gets through inheritance. And they made sure to roll in interfaces on that as well. I can pick, I want to know my cooler is not updating right. Let me go take a look at its update method. Okay, well, it's actually the level controller's update method. Cooler doesn't add to that. But I got this handy implementation selection, and I can flip through the different implementations. So I have total transparency into my actor and how it's put together. We're not yet doing like pre-launch init and stopcore and stuff like that yet.
that's also one of those things that's on the
It's on the list that's coming.
that people want to help out with.
And people want to help out with, reach out to talk to Casey, the man's right here. Also, is there a way, couldn't find one, is there a way to double click on something and get to the block diagram?
Not double click, but you can right click. You should be able to right click on the lower left.
Here?
Yeah.
Oh, show method and project. Okay, so take me right to the method and project. There's a nice bit of acceleration. I knew there was one, but I couldn't remember it. And I didn't go watch your video because I thought I remembered everything. All right, so here is, oh, dang it. Is that the one I wanted? Yeah. So here's a block diagram. And yeah, so if I'm poking around in here and I'm like, oh, I'm doing some work and I need to go post an update. I think, this panel comes up and let me go find one of these. I can go open this. And here's where the update utility comes into play, because I can, if I'm noodling around a block diagram, I had a demo plan and of course I'm not following it. I can right click on it and I can go to the payload method, and again, it'll open this guy and I can go right to the one that I care about. So between these two tools, you can and the project itself, you can navigate around your actor framework system and get to the specific method you need in the specific actor in the specific location. I love Browse the browser. As usually the original writer of the code, I don't directly use it that much, but I've handed it off to customers, especially this one that we're working on code together, and he's just ecstatic because we have to communicate through emails and stuff half the time. So it really helps with drilling down on the stuff. So check it out. Where to find this stuff? In my very limited time left, I have like 2 minutes. Again, vipm.io. There you go. That's where you're going to find most of this. Let me get through this and I'll take your question. Get that man the mic in the meantime. For things that are not here, like the MGI panel manager, you can go to personal repositories. vipm.io will usually direct you to the appropriate repository. Mine are here. You can see the MGI panel manager is the first one listed. Events for UI actors is there. If you wanted network endpoints to go see the unit test for it, they're there. AF tool support is the actor hierarchy inspector. And if you want to get hold of the actor tester and work up its changes, go here. That gentleman's question.
So I haven't used Active Framework, but I operate a lot of programs that need to operate on a long-term stable mentality.
Okay.
And I'm seeing a wonderful library of community tools that exist out there to really accelerate and enhance as things like either for debugging or in a lot of cases as inherited hierarchies. The concern I always have when I see these kind of structures is community is great because you have all this grassroots effort, people doing this either as a hobby or in cases as a side project of their work. But the problem with that is there's no guarantee it's going to continue to be supported long term. How much of this wonderful collection of tools out there are open source such that if development stops, say the company implodes, what have you, it can be internalized and carried on when I may need to operate for 10 years?
Good question. VIPM.io, one of the things they really want when they post the tools, and I think it's the standard that we should be moving towards, is to make that source code available. So even there's enough that goes into, I'm working on an open source actor framework project. I'm actually working on an AF module for Antidoc, which we just started on. I don't have anything to show off for you yet. Check with me in a couple of GDev cons and I should have something to show you. I haven't made my stuff necessarily open source yet, and some of the other tools aren't, but the repos are available. That's VIPM.io really wants you to show and share your repo as a way of demonstrating, hey, even if I'm not supporting this, it's available and you can take over and fork your own versions if you need to.
I can say all the ZIA stuff is open source.
And Casey says all the ZIA stuff is open source. And I just haven't looked into enough of what I'd have to do to administer that to be quite ready to pull that plug. But I mean, if somebody really wants to work on one of these and wants to talk to me, I'll figure it out. Okay, I am out of time. I'm over time. Thank you for sticking around. I am Alan C. Smith. Here's where you can find me. Find me on LinkedIn. Tell me you saw my presentation. We can be friends on LinkedIn. I am a proud sponsor of both GDev cons, both the one in Colorado in July and the one in Stuttgart in Germany. I'm a longtime sponsor of both of them because I believe in these sorts of direct contact, meet the person, have a conversation, go out in the hallway and talk about whatever cool thing just occurred to you based on that conversation. And I am presenting at both of them as well. So that's the next time you can see me up on a podium. I think I have to get the hell out of the room, but I'm willing to stick around for questions down in the hallway if any of you have any questions for me. Thank you so much for coming. Go test your day.